Okay, moving right along. Now we have the job of finding the f prime of this. Prove that if function x is equal to 1 over x, let's just find the f prime of it. So again, let's type in our standard. So we have our limit over, well, I mean limit as h approaches 0. Alright, so we have here in the numerator function of x plus h. I think on my next video I'm just going to have this prerequisitely already here, and all of this is going to be over h. Alright, so now we just need to plug in 1 over x, right? So that's a simple task. So let's take our limit here, and now we're going to have a fraction, and we're actually going to have a fraction and a fraction, and this is going to be 1 over x plus h, right? It's going to be subtracting 1 over x. And then in our numerator, denominator, we will have h. Alright, so I think I'm right so far. So, one thing we can do to get this h out of the denominator, we can multiply the numerator and the denominator by 1 over h. So that cancels out with that, and this is going to be, of course, distributed. So let's look how that affects it. And I think I might have to take up 2 slides with the way it's looking so far. So if we do that, let's see. So this is no longer within a fraction once we do that. So sorry, having a bit of trouble here. There we go. And let's put all this in a parentheses just to match with whatever notation we have to match with. So we have h's now in the denominator of these two fractions. So there we go. And now to do anything else with these fractions, I think it's actually best to bring to add the tops if we can, or put them together. So basically we need to make a common denominator. So let's see here. So now this side, what it's missing is an x. So let's put an x here and multiply top and bottom by an x. What this side is missing over here is an x plus h. So let me put that in fact, I'll put it just like I have it over there. So it's missing an x plus an h, and now I also have to have that, of course, in the numerator, x plus h. Then now we can actually combine them, right? Yeah, I'm definitely going to have to use a second slide. So now, of course, when we combine it, we add a negative, and this negative is going to be distributed. So keep this in mind. This negative here came from here, and this negative will have to distribute to this x and that h. Alright, so let's get on to another slide here. So good so far. So almost forgot. So now we can see that this x is going to cancel out with this x because it's a positive x, and this negative x, so that cancels out, and we're left with a negative h in the numerator, right? And let me just show the intermediate step as that h gets canceled out. So these x's were removed, and now we have our h's here, and we could get rid of them. So that h can cancel out with that, and all we're left with is negative 1 in the numerator. So what do we have right now? We have x plus h over, negative 1 over x plus h times x. So I think we have as much information as we can to now determine what the limit is. So let's just plug it, now that this function or equation, not equation, now that this expression here is within, you can stick 0 into the h now, and it's within the domain. You can look at it that way. We can now plug it in, so let's just go ahead and do that before I get tongue-tied again. So we just plugged it in, negative 1 over x plus 0, and that will come out to what? This becomes x, so we have x times x, which is going to be negative 1 over x squared. And we have just solved that problem, and we can look at the original f prime of x equals to negative 1 over x squared, and now we just solved it. Alright, so see you in the next video.